Okay, so this is part 2 of the normal model video. So I'm going to open up the questions. We ended with answering what percentage of players would we expect to score more points than Victor Oladipo. And as a recap, we found his points per game. We found the z-score for his points per game, which was 1.37. We looked at the table. Let's find that table. And we said, okay, let's look for a z-score of 1.37. So these were all negatives, so we scrolled down to positives. And we're starting in this column, so we found 1.3. Then we moved all the way over so where it matches with 0.07. And we found that 91.47% of players should score less than Victor Oladipo. We know it's less because the picture here, the picture up top, shows that the shaded area is to the left of the z-score. So the left means less than that z-score. So 91.47% should score less than him. So what's left over? We could just do 1 minus 0.9147. And we got that our answer was 0.0853, which as a percentage is 8.53%. So 0.0853. So that was that. So the next question, it's a little more complex. So we're still assuming a normal model. What percentage of players would we expect to score fewer points than CJ McCollum, but more points than Dario Saric? So let's first find the amount of points that they both have, and then we'll convert those into z-scores. So for McCollum, his points are, let's see, McCollum. So his points, so I will search for McCollum, Control F, McCollum, so here he is, and he scored 21.4 points. So I'll write that down. And then let's find Dario Saric. So how many points did he score? So he should score less than 21.4, right? Because we're looking for the people that score less than McCollum, but more than Saric. So he should score less than 21.4. So let's search for Saric. Okay. So Saric is way down here on the list, and if I look to his points, 14.6. So Saric was 14.6 points. So now let's find their z-scores. So knowing that McCollum's is 21.4, I'm going to find the z-score in the sheet. Okay, so our standard deviation is 4.95. So I'll just highlight that, the mean of standard deviation. So the standard deviation is 4.95. So what is McCollum's z-score? Well, his z-score equals what he actually scored, which was, forgetting, 21.4. And I'll put this in parentheses. Minus the mean, which was 16.3. And that's all divided by the standard deviation of 4.95. So McCollum's z-score is 1.03. And then let's find Saric's z-score. Saric's z-score, well, he scored 14.6 points. So it's in brackets 14.6 minus the mean, which is 16.3, and divided by the standard deviation, which is 4.95. So Saric's z-score is negative 0.34, and we'll round these. We'll say 1.03, negative 0.34. Okay, so now what we're going to do, I'll draw this out to make sense of what we're doing. So let's start by talking about McCollum's z-score of 1.03. So I'm going to use paints again. So if the mean is right in the middle, so the mean is here, and then let's make a line for McCollum. So McCollum is 1.3 above. So he's maybe somewhere here. The z-score is 1.03. So if we find this z-score of 1.03 in the table, that's going to tell us what percentage of people should have scored less than a z-score of 1.03. So let's go ahead and find that. So I go to my table, and I'm in the positives here, and I'm looking for 1.03. So 1.0 are my first two numbers, and then match that up with 1.03. So it's going to be this column here, because you see the 0.3 is up here. So where was I again? 1.0, match it with 3. So it's saying 0.8485. So 84.85% of players should have scored less than McCollum. So less than a z-score of 1.03. That's stupid. 1.83. That's going to give me, what did I say? 0.8485. 0.8485. You could think of this as a percentage as well. 84.85%. So that's the percentage that scored less than McCollum. But we don't want that. We want less than McCollum, but also more than Saric. So what we're going to do is with Saric's z-score of negative 0.34, let's look back to the paint thing. So instead of taking everything that's less than a z-score of 1.03, we're going to start with that. So that's 0.8485. 485. So we'll start with that. But then we'll look for where's the z-score of Dario Saric. So negative 0.34. So let's say it's like here. So if we start with everything, all of this data to the left, 0.8485, oops, it's this whole thing. We're going to subtract away whatever is less than a z-score of negative 0.34. Right, because if we have all of this data here, we have all of this, but we don't want all of it. We actually just want this sweet spot that is in between these two values. So we're going to take the bigger number, everything that's less than 1.03, and we'll subtract away this kind of area here. We'll subtract away this area here, because all we want is the green. So let's find what is this red area here. What are we going to subtract away from 0.8485? So if I go to my z-score table, I'm going to look for negative 0.34. So these are all positives. Make sure you're looking in the negatives. It's on the other sheet. So negative 0.3 is down here. Negative 0.34. I'll match it up right here. So it says 0.3669. So 36.69%. 36.69%. So less than negative 0.34. What did I say? 36.69? .3669. So again, what I'm going to do, hopefully this visual helps, is I'm going to take this blue area, right, this whole 0.8485, and I'm going to subtract away the red, which is 0.3669. What that's going to leave me with is the green, which is what I want. Less than McCollum, less than the 1.03, but more than the 0.34. So I'm looking for just this area left over. So if I go ahead and subtract those two numbers, what I'm going to get is equals 0.8485 minus 0.3669, and that is going to be 0.4816, which is 48.16%. So 48.16% of players should fall in that green area being less than McCollum, but more than Saric, so in this green area here. So my answer is 48.16%. 48.16%. So the last question says, assuming a normal model how many minutes would you have to play to be higher than 30% of players? Let's just say points. How many points should you have to score? How many points should you have to score more than score more than 30% of players? So to figure this out, we are going to find the percentage in our z-score table. We're in the z-score table. So remember that these numbers here, these numbers are all percentages. It's the percentage of values that should be less than your z-score. So if we want to be more than 30%, if we want to have a z-score greater than 30% of the data, we're going to find the value that's closest to 30% here, and then find the z-score that's associated with that percentage or percentile. So I'm going to look for 30%, that's 0.30. So here it's like 0.20, 0.30. This is pretty close, 0.3015. I think that's going to be the closest. So what's the z-score that is higher than 30.15% of people or values? That would be negative 0.52. It matches up with negative 0.5 and 2. So the z-score that we're talking about, z-score equals negative 0.52. So we need to find what amount of points is associated with a z-score of negative 0.52. So how we're going to do that is z-score of negative 0.52. So whenever we talk about z-scores, that center point is the mean. The mean is our center. So if I look at Paint, I am here at the mean. So this is a mean. The z-score is 0. I'll change to black. The z-score is 0 here. But I want a z-score of negative 0.52. So somewhere over here. So if I want to find that z-score of negative 0.52, that is 0.52 standard deviations below the mean. It's 0.52 standard deviations below the mean. So what I'm going to do in Sheets is I'm going to start at the mean, and the mean, which we found earlier, is 16.3. And I'm going to subtract, I'll make sure to put an equals so it does calculations, equals 16.3 minus 0.52 times the standard deviation. So I'm 0.52 standard deviations below the mean, and I know it's below because I'm subtracting. So 16.3 minus 0.52 times the standard deviation of 4.95, and that gives me a value of 13.73. We'll round it, 13.73. So what that number means is that if I score 13.73 points per game, I should score higher, more than 30% of the players. So that is my answer there.